Good day everyone. In previous videos, we studied the application of Newton's laws like the double inclined plane system, and lately we have the Atwood machine. And today, let us have another application problem with Newton's law, the inclined-hang system. This is still on the topics of the dynamics of motion. Now, there are requirements on every solving problems on using the Newton's laws of motion. In dynamics of motion problem, there are requirements that are very important. The three laws of Newton's, which is the first law, the second law, and the third law, and also the free body diagram of an object, meaning the knowledge of constructing the free body diagram is very important because we will be using the second law of Newton and first law. And the first law and second law, it involves net external force. So, in order to solve problem, we need to provide the free body diagram of the object. Aside from that, we need also have the idea on friction, because remember that for every contact between particles, friction is always present on the activity. Okay, then in Atwood machine, we learned that the acceleration of the system is the acceleration of gravity multiplied by the difference between mass B and mass A divided by the sum of the two masses. So this is the acceleration. And we have also the relation that can calculate the tension in the cord. Now if you notice in the numerator, it is actually the difference between the gravitational force between the mass B and mass A. So therefore, we can say that the acceleration is the net external force, because when you subtract the weight of the two objects, it is the net external force of the system divided by the total mass A and B. So practically, the acceleration is coming from the unbalanced force divided by the total masses. And the tension in the cord, or we call this as the second law of Newton. The net external force is the product of the mass times the acceleration. While the tension can be computed by the product of the mass of object B times the acceleration plus or minus the mass of B times the acceleration of the system, which is coming from the formula. Now, take note that we have the plus or minus. We will be using minus if B moves downward, and we will be using plus if B moves up the system. Okay, so this is it. Now for the incline-hang system. Now if we have an inclined plane with a pulley attached on it, and the pulley, take note, is a frictionless pulley, then we have the angle of inclination of the inclined plane, let that be equal to theta. Okay, now if we have an object A and B and connected by means of a rope or string, and the rope or string passes over the pulley, and we will disregard the friction between the rope and the pulley, and also the friction of the pulley itself. Now we call this as and we have the suppose we have the friction between the objects along the inclined plane, so we have the coefficient of friction, or the mu. Mu is the coefficient of friction. Now we call this as the incline and hang object, so incline-hang system. Okay. Now, meaning if you release the support of the system, then there's a tendency that the particle will move down. Okay, or maybe the particle will move on, A will move up, or maybe move down the plane. So it depends upon the relationship between A and B, so the amount of A and B, and also the friction, and also the angle. Those are the variables that uh, can cause the object to move along the incline up or along the incline down, or B, move up or B, move down. Okay, so the task is to compute the acceleration of the system and also the tension in the rope. Meaning, given the mass A, given the mass B, given the angle of inclination, and given the coefficient of friction, what will be the acceleration and what will be the tension in the rope. Okay, take note, as I've said, the acceleration is very, very important. No, for every problems in dynamics, we should know the acceleration, because from there you can solve other physical quantities like unbalanced force. You can solve the velocity, the displacement, and other physical quantities on the kinematics. Okay, in fact, the tension can be solved using the acceleration of the system. Okay, so we will assume first, because we don't know where to move of the system, whether A moves up the incline or maybe down. Then at first you can have the assumption. So meaning, if we assume that A will move up the plane, then B should be moved downward also, for consistency, because they are connected with each other. Okay, so then the B will move downward and A move upward up the plane. So therefore, since A will move upward, then it follows that we are very sure that the net external force is along that axis, okay, along that line. So we have the net external force on mass A, and we have also another net external force on mass B, which is downward. Remember, according to Newton, the direction of acceleration is also the same as the direction of the unbalanced force. Now, take note that we need, in order to solve for the acceleration, we need the net external force. So therefore, we have to provide the free body diagram of the two objects. So I overlay the Cartesian and notice that the x-axis, positive x-axis, is aligned to the inclined plane and it is directed upward as positive. The reason is I ensure that the net external force is along the x-axis. Meaning, if I sum up all forces along x, the sum is also equal to the net external force of mass A. Then, perpendicular to that, I have the y-axis. And the y-axis is perpendicular to the inclined plane. Okay? Now, what are the forces on the object? Now, take note that we have the mass, so therefore, we must have the gravitational force. Assign that as W sub A. Okay? Another is since we have the contact, no? we have the string or rope connected to object A, and remember, we assume that A will move upward, then it follows there must be a force that applies to the A to move upward, and that is the tension in the cord. So assign that as big letter T. Or take note, because since it is towards or above or going to the higher level of the inclined plane, then we have the positive T. And the normal force is also occur at the interface between the object A and the inclined plane. And remember, the normal, it is a force which is against and perpendicular to the surface in contact between objects. So, meaning, the normal force should be towards the positive y-axis, and it is a positive force, and it is along y. Now, since we have the normal, and we have the coefficient of friction, remember the coefficient of friction is the ability to provide friction between the object. Meaning, when we say frictionless, the coefficient of friction is very, very low. Now, if we have the coefficient of friction and we have the normal, then it follows that we must have the friction. Now remember that friction is mu times the normal. Okay? And the friction is always against the motion of the particle. Since A will tend to move upward, then friction should be directed downward, down the plane. So it should be negative F as the frictional force. So therefore, there are only 4 forces on the object. Okay? Be sure that when you construct the free body diagram, all forces should be reflected. Remember that in the free body diagram, we want to obtain the net force. And remember that the net force occurs along the x-axis. Along the y-axis, net force is 0. Because there's no possibility that the object will move towards positive y or maybe negative y. So the direction of object A is along the x-axis only. So therefore, if you sum up all forces along y, the sum should be 0. Okay. Now notice that the tension is a positive, okay, because it's towards the positive x-axis, while the normal is positive because it's directed towards the positive y-axis, and the friction is negative because it's directed towards a negative x-axis. Now look at the weight of the object. The weight of the object has 2 components. No, we have the component along x, and we have a component along y. Okay, now take note also that whatever the angle of inclination will be the same angle from the action of the gravitational force towards the y-axis. That is by geometry. Meaning, if you reduce the angle of inclination, that angle between the y and weight also decreases. Meaning, if the angle is 0, then that angle W with respect to the y-axis is also 0. Then it follows that the surface now becomes horizontal. So again, it is very important to know that whatever angle of inclination will be the angle of the weight with respect to y. Okay, so take note, we have 2 components, the Wy, which is negative, no? down the plane, down below the origin, and for the x component is towards the negative x-axis. So these are the 2 components of the gravitational force Wa. We have Wx and we have Wy. Okay, now take note that, meaning we can eliminate now the gravitational force because we already reflected the components, the y component and the x component. So meaning we must solve Wx and Wy in terms of Wa. So Wx, remember, in our vector analysis, kindly go over the videos on the vectors analysis, that the components of a vector can be solved using the sine and cosine. Okay, because remember that the components and the vector form a right triangle, and take note, the right triangle has an angle of theta coming from the y-axis, which means that solving for sine, the sine now is opposite, hence it is sine. Okay, and the Wy is Wa cosine theta, because Wy is adjacent to the angle. Okay, this is in contrast in our understanding in vectors analysis. We use sine for y and cosine for x because the angle we use is a reference angle, meaning the angle coming from the x, but that angle is coming from the y. Okay, now remember that weight is mass times the gravity, meaning we can replace Wa by ma times g. So therefore we can say that Wx is mass A times gravitational acceleration times the sine function of the angle of inclination, while y is mag cosine of theta. So these are the values, no? The values of Wy and Wx. So the only factor is the mass of the particle. Now remember that given the mass is A and B, so therefore, and we have also the angle, So practically, Wy and Wx are known. Okay, now let's proceed to the next object. So meaning those are the free body. We can now remove the Wa, no, because we have already the components that represents the weight of the object. Okay, for object A, B, you notice that X is downward. Why? Because the direction of the motion is downward. So we ensure that the net external force is along the positive x-axis. Now the forces are the weight, which is positive because it is downward along the positive x-axis, and the tension in the cord is, or string, is negative. Now remember that in the hanging object, there's no force along y. Unlike mass A, that we have the normal force and we have the component of W along y. Okay, so there are only two forces on mass B. So okay, then we can rearrange this one. Okay, we can separate the two objects. So the upper part is the free body diagram of A, and the lower is the free body diagram of mass B. So from there, remember that we need to sum up all forces along X and forces along Y. Now in both free body diagram A and B, if you sum up all forces along Y, the sum is equal to 0. Okay, so therefore all we need to do is to sum up all forces along X. Now take note that in free body diagram A, the normal force is equal to Wy, because the sum of them must be 0. So therefore it follows that N is equal to Wy, or mg cosine theta. Okay, summing up all forces along X. What are the forces along X in free body diagram of A? There are three forces. Look at the x-axis. We have the T as positive, we have Wx as negative, and we have negative F, or the friction, because we have only three, no? So that's it. We have the forces along X, which is equal to T minus Wx minus the frictional force. And remember that Wx is mass times gravity, while friction is mu times N. Okay? So W sine theta for X, and for friction is mu times the normal. Okay? But W is mg. Take note of that. So meaning it should be T minus meg sine theta minus mu, and take note normal is equal to Wy. But Wy, remember in our previous slide, it is you have to add mg cosine theta. So kindly add mu ma, then add the gravitational acceleration multiplied by the cosine of theta, and that is the net force, or the sum of all forces along X from the free body diagram. Okay, now remember again that another definition of the summation of forces along X, it is also the same as the net external force of A, because we ensure that the object will move, or we assume that object will move upward up the plane, then the net external force must be along that axis. That's the reason why we assign positive X. And remember that the net external force from second law is mass times the acceleration. So therefore, we have two definitions of the net external force along X, or the sum of all forces along X, from the free body diagram and from second law. Then we can equate the two. Then we have T minus meg sine theta minus mu mg cosine theta, which is equal to the mass of the object A multiplied by the acceleration. And notice that there are two unknowns, the tension and the acceleration. Okay, some of them, or the rest are known, because we know what is the mass of A, we have the constant acceleration 9.81, and we have also the angle of theta, we have the coefficient of friction, and the only unknown is only A and T. Again, we have one equation with two unknowns, so meaning we cannot provide a definite solution of that. There are infinite solutions, so leave it as equation 1. But same in Atwood machine, we still have another free body diagram, and the equation can be formed from that, can provide another equation which has the acceleration and tension variable. Okay, so summing up all forces, remember, if you sum up all forces along y, the sum is equal to 0 again, because there's no force along y. So therefore, we'll focus on the summation of forces along x. Summing up all forces along x, we have only two forces. Tension is negative, and we have WB, or the weight of the object, is positive. Okay, but W is mass times the gravity. So therefore, this is the net external force, or this is the sum of all forces along x from the free body diagram. Now remember again that the net, the sum of all forces along x is also the net external force, and the net external force is mass times the acceleration of the object B, and that is the second law. Again, we have two definitions of the sum of all forces along x, then we can equate the two. So we have negative t plus mbg times we have the mass b times the acceleration, which is equal to mass times acceleration. Okay, so again we have another equation that has two variable, and we have acceleration again, acceleration a, and we have the t. So we can have it as equation 1. So therefore, we have now two equations, no? Two equations that involves the same variable. We have equation 1 has an equation variable of a and t, and equation 2 we have variables a and t also, tension and the acceleration. So these equations are simultaneous, no? Because according to mathematics again, equations that have the same variable are simultaneous. Now, if the two equations are simultaneous, then we can apply the principle of systems of equations. The system of equations, we have the methods of finding the solutions. We have the by elimination, and we have the by determinants. In this case, we can use the elimination by addition, no? Because in elimination we have addition and substitution. So in that case, just add it algebraically. So combine the left member and combine the right member. So it follows that we can cancel the tension in the cord. Remember that the purpose of adding is to eliminate one variable. So we use add in order to eliminate tension. So combine all terms in the right side, combine the left, then we come up with this. We have the mb mass b times g minus meg sin theta minus mu mg cosine theta in the left member. The right, we have the mass b times the acceleration plus the mass a times the acceleration. Okay, so this is now the equation which is the result after combining equations 1 and 2. And take note that t was eliminated. Hence, we have only one unknown, and we have the acceleration. So all you need to do is to solve for the acceleration a. So before that, we can combine like terms. The like terms are g, no, in the left member, acceleration due to gravity, and we have the a as the acceleration of the system. So take the common factor, and after that, solve for a by dividing b plus a. Then this is the acceleration of inclined-hang system, which is equal to g multiplied by the mass b minus mass a sin theta minus mu mass a times the cosine of theta divided by the sum of the two, a and b. Okay, so this is called as the acceleration of inclined-hang system. Now the tension can be solved using equation 1. So the simplest way, so although you can use equation 1 or 2, but we can use, for simplicity, equation 1. Solving for t, then we come up with t is equal to mb minus mbg times mba. So this is the tension of rope for inclined-hang system. So these are the answers, or the formula, the relation that can solve acceleration and tension. So take note that the only requirement to solve for a are the masses, the angle of inclination, and we have the coefficient of kinetic friction of between surface. Okay, so again, this formula is applied only if the particle travels, no, A will move up the plane while B will move downward. Okay, so and the tension also can be computed using the formula T is equal to the mass B times the acceleration due to gravity times minus mass B times the acceleration of the system. So meaning after solving A, then you can solve for T. Okay, now how can we say that this formula is applicable to that? Now take note that we don't know whether to move up or to move down. Okay, so in order to understand if the particle will travel upward, then you have to use this formula, no? If you remember that the assumption is A will move upward, but take note it depends upon the values of the masses, the angle of inclination, and the coefficient of kinetic friction. Okay, now all you need to do is to substitute that given to this formula. Now if you have a positive result, meaning if the answer is positive, then it is true that the object A will move up or ang B will move down. Okay, now if the answer is negative, then it signifies that this formula is not applicable. We need some revisions. Okay, some revisions. Now notice that the formula, look at the formula. In the numerator, remember, just like in Atwood, the numerator is the net external force. And take note, there are three terms. If you distribute the G again, multiply it terms by G, then it will becomes gravitational force. It is a force, no? Mass times gravity is a force. Now, the mass times mass B times acceleration due to gravity is the weight of what? The weight of mass B. Meaning, you look at the formula, it is the weight of mass B subtracted by what is mg sine theta. Mg sine theta, take note, is the component of the weight along the y-axis. Okay, so it is negative because in our assumption, because the component of weight is towards the negative axis, x-axis. And the third term, we have the, take note, it is a frictional force. Okay, it is a friction. Now, it is mu times the mass of A times the gravitational acceleration times the cosine of that. So it should be subtracted because it is downward. Okay, so meaning the mass B was subtracted by two forces. They are the component of weight of mass A and the component or the friction between the object A and the inclined plane. Okay, now if the system will have a reverse direction, then we need some revision on that. So, okay, now let us apply first the problem. Suppose the problem mass A is 8 kilograms while mass B is 7 kilograms. So the object in inclined plane is heavier compared to the hung object, which is 7 kilograms. And we have the given angle 40 degrees, and we have the coefficient of kinetic friction as 0.1. So what do you think? Will 8 kilograms move up the plane or down the plane? So questions, no? Now to understand, to learn if this object, the system, will move in our assumption that it will move upward, then you have to use the formula. Remember, our formula is, we have the formula derived lately. So we have the G mb minus m sine theta minus mu ma cosine theta divided by mb plus ma. So all you need to do is to substitute everything, then calculate. Okay, so 7 kilograms for mass B, 8 kilograms for mass A. Now calculate this one, and the result is 0.81 meter per second squared. So since this is positive, then it is true that the system follows our assumption. Meaning, 8 kilograms will move up the plane while must be, which is 7 kilograms, will move downward. Okay, that's it. So because we have a positive result, meaning this is okay because this is greater than 0, meaning you can use that formula. Okay, now suppose we have another problem. If we are about to calculate the tension, then we have to use the formula. Since we have already A, substitute that the value. Okay, 7 times 9.81 minus 7 times 0.81, then the result is 63 newtons. That is the tension in the string or rope. Okay, so then another example, suppose we have 15 kilograms and the other is 7 kilograms. Do you think that 15 will climb up the plane or down the plane? So in order to answer this question, then all you need to do is to use the formula that we used previously. Okay, the mass B minus mass A sine theta minus the mu times the mass A, then cosine of theta. So replace everything, then the result is negative. So what's the meaning of that? Since the answer is negative, then it follows that no way that 15 kilogram will climb up the inclined plane. Hence, there's a possibility that it will move downward, or maybe it is at rest. No? So it depends upon the situation, the result. Okay, now, so therefore we can say again that because this result is less than 0, so we have to reverse the direction. Now to reverse the direction is no need to change the formula, or no need to derive it again. All you need to do, okay, meaning we cannot use that value, no? It is not true that the acceleration downward is 1.69, because take note that the friction now will reverse. When the particle down the plane, then the friction should be always opposite, so meaning it will become negative, opposite direction. While our weight, take note the weight, the component of, why is it that the object 15 will move downward? It's because of the component of the weight, and it should be downward. So we can assign that as positive, then it should be the component, no? So meaning the revised acceleration now is equal to the 9.81, or the Earth's gravitational acceleration, multiplied by the mass A sine theta. Take note that mass sine theta times acceleration is the component of weight along the x-axis, and this time downward. So we will assign that as positive, so therefore it should be plus. Then the friction is, remember, is against, no? Reverse. So it's because friction is always negative. So friction is mu ma g sine cosine theta. So remember, g will be distributed to the grouping symbol, so it will becomes a force. Okay, it will becomes a frictional force, so it is negative. Then minus mb times g, it is the weight of the 7 kilograms or the hang object. So this is now the revised formula, and it is always divided by the sum of the object. Meaning, if you start it again, deriving on the first step, assuming that the object will move downward, then you will come up with the same formula, and we are very sure. Okay, so take note again that the numerator is the net external force, and the denominator is the total mass of the moving object as a system. So again, the reason why the object travels downward, it's because of the component of weight along that axis downward, and we have the subtracted by friction and subtracted by the weight of the hanging object or hang object. Very clear. Okay, so then all you need to do, so this is the formula if the particle moves down the plane of the incline-hang system. So all you need to do is to recompute again using this formula, revised formula. So 15 now, 9.81 times 15 sine 40 minus 0.2 cosine 0.1 for the coefficient of kinetic friction times 15 times cosine of 40 minus 7 divided by 15 plus 7, and the answer is 0.67 meter per second squared. Meaning, that is the acceleration of the body particle while moving down the plane. And if you compare it with the previous, okay, it is now a smaller value, means it moves a slow motion compared to first example, because the greater the acceleration, the greater the velocity obtained. Okay, so the smaller the change in velocity. Okay, then okay, so we have this. Okay, this is the same as the one. Now for the tension, we will be using plus, okay, y plus, because take note that in order for the 7 kilogram to move upward, then we need to overcome the weight and also the net external force of the object in order to solve for the tension in the cord. So that's why we have the plus sign. So the tension can be computed using MBG plus MBA. So then substitute the values using our result 0.67 A, then the result is 73.36 newtons. Okay? These are the answers to the problem. So let's have the summary. Okay? Meaning, if we have that incline-hang system, if the device will move in our assumption, meaning A will move up the plane and B move down from hanging, then we can use the formula. Our derived formula, B minus A sine theta minus mu ma cosine, all of them multiplied by the acceleration due to gravity to become a force, then divided by the sum of the masses. And the tension should be minus, it should be MB. Take note, we are always talking with the mass B. So mass B, G minus MBA. Now for the system that mass A will move downward, then we have this revised formula, no? So again, we have the weight, the component of the volume, which is MAG sine theta, subtracted by the frictional force and the gravitational force of the hanging object MB, divided by the total mass, and that's the acceleration. And the tension is, take note, it is plus, no? Plus, because we tend to move up, so the weight should be included, and also the net external force in order to compute the tension in the cord. Okay, so that's all. So thank you for listening. See you on my next video.